code is going to actually take you to a virtual mock-up. I think it's a mock-up of a kitchen if you guys are using it. And basically, it allows all the team members of the project to basically assess if the different components of the project, if you have complaints about the size of certain things, you can basically make your comments and go through the whole feedback process with the contractor. Of course, the model which we've made available through the QR code is actually edited in a manner that you're not able to put your comments forward. But you're basically able to also access it online and basically take measurements and check for clearances and see if the different interests of the different parties involved are being catered for in terms of CNS, MEP, and architectural finishing. Okay, so this is for Gen 2. So now we move on to Gen 3 for PPVC, which is same system. We basically applied it in a project in Sengkang, in Fernvale, called Fernvale Glades. The project is now under construction. The site is actually located here. Okay. For those who are familiar with Sengkang, this is Seletar Mall in Fernvale. This is Fernvale LRT station. Okay. Okay. So when the housing board gave us the site, they actually gave us a site with a very, very odd shape with a lot of kicks to accommodate some of the existing areas around. And they actually absorbed, as part of our contract, a rectangular shaped common green space, which is actually a small park. Okay. So the way we designed it is when we were planning the site, we thought, okay, this site is one of the first sites that you will see when you basically arrive into Sengkang. So we thought, okay, next door you have a business too. So this area is probably going to be very, very noisy. And so we decided that we wanted to treat the eastern and the western and the eastern edges of the site as edges. So we wanted to basically buffer off the noise from here, and as well as the activities that are happening in the senior home. Okay. So from there, we also decided that we wanted to position the blocks in a manner that as you drive into the site, you're basically greeted not by an end wall, but you're basically greeted by a block that is tilted to face the street junction. And then from there, we also wanted to create a sense of arrival from the site, because we also know, based on the URA master plan, there are going to be commercial facilities located in the north. We also found out that there is also commercial facilities located in the south. And the idea was to receive people crossing from across the street, receive them through the blocks, and allow them to filter through the site, experience the common green, and then reach the commercial site at the bottom. So to do that, what we did was we actually reshaped the common green from a rectangular plot into a circular plot. And we basically reconfigured all the blocks in the middle, at the heart of the site, to basically face this gigantic common green. Okay, and then from there, you basically have green belts that basically filter out from the main green space. And the connection is done through. So this is the site plan, where we basically reshape the entire common green. This is the launch brochure, and this is what we envision the common green will be, where each of the residential blocks are basically clustered around it, overlooking this main expansive common green space in the way we planned it. Okay. Now, to design the units themselves in terms of PPVC, this is around the time URA started to impose that all government land sale sites must use PPVC construction if a developer wants to make use of 10% free balconies in the project. So of course, all the developers we worked with said, we want to maximize the balconies, we have to use the technology. So then what we did was we actually started to bounce around ideas with our colleagues working on private sector projects, and to extract lessons from each other so that we can move forward, both as we embark on projects in the private housing market as well as the public housing market. And so the key that we realized was basically to line the columns up in each of the as we plan the different units out. So basically, this will become one module, and one module. So as we did that, there are a few projects which are under construction. This is Park Botania, which is in Fernvale in Sengkang. Okay, this is just 4 residential blocks. Okay, this is the brochure plan. If you observe from 1 bedroom, this is 2 modules. Okay, 2 bedroom, 3 modules. 3 bedroom, 1, 2, 3, 4 modules. The kitchen is another module in itself. The same if you look at the 4 bedroom, all the columns and the way the spaces are designed are completely lined up so that we can seamlessly modularize them for DfMA construction. Okay. This is another project. This is Sterling Residences. It's also under construction. So it's basically 3 towers lifted up on stilts, And then, so it's 3 towers lifted up on stilts, such that you can free up as much of the ground floor as possible for activities, and people can filter through, of course, the residents, the people who are rich enough to afford a home in this kind of place. They can basically filter through the site and basically seamlessly enjoy the activities that are all on the ground floor. But if you take a look at the way the units are designed, they're also fully modularized. In the case of the 4-bedroom unit, they actually do this entire area as a modularized space. So each area can be modularized, where you can basically do up finishes for the walls, the floors. For the bathrooms, you can install the tiles, you can install the WC, the showers, the shower areas, the basins, and such. Okay. This is twin view in West Coast Vale. Same approach. Okay. Buildings on stilts to free up the ground space. So if you look at the ground floor plan is all columns, and you can just basically walk and filter through and basically enjoy all the facilities. And basically this is what it looks like on the ground. Similar approach, if you take a look at the units, they're all also fully modularized. Okay. So the idea is to think about the architecture and the engineering all at the same time, to think in multiple levels simultaneously. Okay. So the general consideration of how to work out a PPVC module, the market basically currently allows for a module of 3.4 meters, that's the maximum width, by 12 meters in length, by 3.325 meters in height, okay, to avoid the requirement for a police escort, as that particular module is being hoisted or being transported from a warehouse or from a pier to your construction site. This is the maximum size that is required. Anything bigger than these dimensions, the module will require a police escort as it is being transported. So for us, when we are working on on housing and residential projects, generally it's not a problem. It is not a problem to keep to these modules. Okay, so these are some of the considerations that we had in mind. Okay, so when we go back to how we designed the flats for Sengkang, this is a prototype plan taken from HDB's so-called catalog. What we did, of course, what we realized that the columns needed to line up. And as the columns needed to line up, we basically had to work out the spaces that are left in between. So what we did was we actually split up the 2 bathrooms and inserted the aircon ledge in between. Each of the bathrooms ventilated into that gap, so that in a way you can also cater for privacy. Sometimes you have common corridors that pass through here. You don't have windows that open up externally anymore. The windows are actually facing each other within their house. They're high-level windows anyway to cater for the privacy. So there it is. They're completely lined up. Now, because we were trying to, we knew that productivity was a buzzword in the housing board. So this is basically how we applied it to 2-room, 3-room, and the 2-room, 2 types of 2-room, smaller one and bigger one, and 3-room. And then we took this idea further when we were designing the 4-room, 5-room, and 3-gen, because we realized that these 3 big unit types can actually share components. So the idea is that the master bedroom, the master bedroom together with the master bath, the common bedroom clustered together with the common bath, and the 3rd bedroom clustered together with the household shelter can be identical across different unit types. So then the idea is that they can share unit types. You have a smaller kitchen and a living dining room for the 4-room. Okay, that's your 4-room. You have a bigger kitchen, you have a living dining space, and then you have a space for a study room. That's your 5-room. You have the same kitchen from the 5-room, apply it. You have your living dining room. You have the 4th bedroom, which is the so-called grandparents' room, and the bathroom module, which is actually shared with a unit that's paired to create the 3-gen flat. So these are how we basically tried to streamline and think about productivity as we do our work methods. So this is the 4-room, 5-room. And then for the 5-room, we basically took the idea further. We said, let's cross-ventilate the entire living dining room space. So thus, we actually cross-ventilated the entire living dining room space. Okay, these are what the modules look like. Okay, this is what the 3-gen flat looks like. One of the things we did with the 3-gen flat is that when you enter the unit, we designed it such that it can have an enclosable foyer, so that multiple generations of families can actually live together, and they don't, if you can't get along, you can actually shut the door, and your in-laws or that other generation can live in that other flat. Okay, it can feel like a different apartment altogether. But same principle, to cross-ventilate the space in the common corridor to allow the breezes through. Okay, so this is what it looks like. So when we take a look as we pass through one generation to the other, generation project A from 2004 to 2016 to 2017, what you notice is the difference between how we basically stitch the different components together. From having to pour concrete to basically stitch so many different components, many of them irregular shape in 2014. In 2016, we streamlined it into a T shape, and then to 2017, we've almost completely omitted it. Actually, now we are still talking to BCA about using this as one component because BCA still wants the floor slab directly in front of the bomb shelter to be in poured concrete. Okay, so that's PPVC. Now we go into the last segment of what I want to talk about, which is mass engineered timber. Okay, mass engineered timber is a new structural material. It's considered as DfMA. It's considered as DfMA, so it is also a technology that you may want to consider for this project. Okay, so of course the advertising pitch is that it's better for the environment. It's better for the environment, more sustainable, better quality, very productive, and they say it's healthier and safer to build. Okay. So the basic principle is to basically use, there are many kinds. When we started to use it, what we were calling it in-house, we were calling it CLT, which is cross-laminated timber. There are many specialists who basically go into this field. And so each one, some people call it cross-laminated timber, some people call it glue-laminated timber, some call it laminated veneer lumber, and so on and so forth. But the generic term that the industry generally uses is mass-engineered timber. Okay, so many different systems in use. But the very, very key principle is basically you have to select the species of where the tree comes from. The technology is from Europe, Northern Europe, so you get it in places like, you get the timber from places like Austria and the Scandinavian countries, okay? And then you basically drive the wood, you basically grade it with strength. And then visual grading is to basically, timber is not natural material, so you have notches, you will have eyes, you have imperfections. So they will basically grade it. If you want higher end finishes, they will basically streamline it according to what level of finishing you want. Remove the defects, and then you assemble it, finish it, then you pack it like an IKEA piece of furniture you buy from IKEA, you transport it, and then you assemble it. So of course, some of the process is basically ship it. Normally it comes from Europe to Singapore, okay? And then you have to watch out for how it's transported because the transportation plan is very, very important. So you don't damage, because if the timber itself gets damaged during transportation, you basically damage the structural integrity of the entire system. And then when you deliver it, okay, you have to check it for quality. And the other thing is how you store it because you don't want the members to be absorbing water while it is stored in your warehouse or in your site. Okay, so some of the things to consider, okay, basically one of the things that happen with DfMA stands for Design for Manufacturing and Assembly. So what happens is that we have to think of construction less as construction and more as manufacturing, more as an industrial process. So it is here when you're adopting these systems where you have to think more in terms of logistics and construction planning so that when you deliver the goods on site, the members on site, you don't store them in a warehouse, absorbing moisture, absorbing water from the ground or absorbing too much moisture in the air before you install them. Then you have to plan how each member is hoisted so that you don't damage them, the critical parts of it, before you hoist them and assemble them into place. Okay, so there are many examples of this in Europe. Okay, they built as high as 9 stories in London for a small office building, a 4-story office building. I'm going to guess that this is probably going to be the scale of your design competition project, about 4 or 5 stories. Okay, office building. Okay. They built an 80-story student residence in Canada using this system. And NTU built a 9,000 square meters indoor sports hall using this technology. It's already completed. Okay. Okay. For startup companies and such, JTC also built one, smaller building. Okay. 5,000 square meters in GFA. Okay. Now, some design considerations when we're designing in MET. Okay. One, fire. Okay. Timber is a naturally combustible material. So as a result, I think this is how it behaves apart from fire, but the traditional means of coating it for fire is necessary. Timber can also be attacked by termites and other pests, insect attacks. weather, because especially in a place like Singapore where you have 6 months of sun and 6 months of rain, how it responds to being in constant, being blasted by water and being blasted by the sun in very, very humid conditions, and basically how the structural system and connections are put into place. Okay, so for fire, okay, we're building a community, a CC right now. We'll show it to you later using this system. Okay, so the key is to basically to encapsulate the entire system. Okay, using the necessary means of protection. But one of our experiences is to basically to supersize the timber members. Because if a timber member burns, you basically get the effect of charring. And what happens is that charred layer basically also temporarily functions as a layer of protection for the column itself. So normally what has to happen is that you have to over-design the structure of the building so that you end up over-design the structure of the building in case of fire, so that basically you use the charred external layers of the structural members to protect the structure itself. Okay. Then the protection for termite and insect. Okay. There are many ways by which to do this, like what we did in Bukit Batok. We basically lifted the timber structure off the ground. We built it on a concrete plinth. You poison the soil, okay, which is not necessarily the most sustainable means of construction. Okay. And then for weather protection, we do basically cladding. The idea is to basically use cladding using aluminum. Other members, for the CC, which I'm about to show you, we basically used aluminum cladding. For the CC a while ago, for the RCC in Bukit Batok, we basically use timber cladding to basically protect it. One thing that happens to MET as it ages through time is that it turns gray. Now, of course, in places like Europe, and for certain clients in Singapore, they appreciate how a building will basically transition or transform from the color of its original state when you build it, and then as it ages, it will basically turn, its color will change in almost like a chameleon-like effect. So there are